Hi everyone, so welcome back to my channel Mathematics Girls Party 3226. So this is basically the second part of that particular video where I have covered the metrics chapter. So this is the second part. I'm going to put the link of the first part in the description box. Make sure you are watching that video first and then you come to this video, okay? So in this particular video, I'm going to cover exercise 3.2 NCERT questions. Question number 12 to question number 22, because from 1 to 11 I have already covered in the first part of the video. The link you can see in the description box. All right, so let's get started with the video without any further delay, because like we have to cover 10 questions approx, right? So yes, this is the 12th question and we need to find the value of x, y, z and w. You can see the question given 3 times the matrix equals, the matrix plus the matrix, and we need to find out all these variables. So let's quickly start with the solution of the 12th question. Okay, we can start now. So the very first thing that we are going to do is the basics I have already covered in the first part of the video. So I'm just going to cover, directly the solution. So again, you can watch the recording, like you can watch the video of the first part, okay? So let's multiply this. So of course, this 3 will get multiplied with each of the entries inside the matrix. So 3x, this is 3y, this is 3z, and this is 3w. So we have this matrix and equals. We have on the RHS 2 matrices given and they are getting added. So we know that the corresponding entries get added. So this is x plus 4. This will become 6 plus x plus y. How? Because this plus this is x plus 4. And this plus this, that is 6 plus x plus y, is this entry. This will become minus 1 plus z plus w. And this will become 2w plus 3. Okay. So this is the matrix we have. And now we know that if the matrices are equal, then their corresponding entries are equal. So therefore, we can write down 3x equals x plus 4. We can write down 3y equals 6 plus x plus y. We can write down 3z equals minus 1 plus z plus w. And we can write down 3w equals 2w plus 3. So let me write down here 3w equals 2w plus 3. Clearly, we can find out x and w first, like very straightforward. This will become 3w plus 2w will become minus 2w. If you shift it to the other side, and this is 3. 3w minus 2w is w, and w is equal to 3. So we have got our w. So yes, this is the answer for w. Now let's quickly find out x. So here this will become 3x minus x equals 4. Clearly 3x minus x is 2x equals 4. So x will be equal to 4 divided by 2, that is 2. So we have got our x as well. Now we have x, we have w, so we can clearly find out y. So here 3y, and then this plus y, if I shift to the other side, it is minus y. This is 6 plus x is 2, so plus 2, because we have already found x. This is 3y minus y, that is 2y. 6 plus 2 is 4. So clearly y is 4 divided by 2 is 2. That means we have y is 2 as well. So we have x, we have y, we have w. Now we have to find just z. So let's find out. This is 3z plus z. If you shift to the other side, minus z. Minus 1 plus w is 3. So it's 3. 3z minus z is 2z. Minus 1 plus 3 is plus 2. So z will be equal to 2 divided by 2, that is 1. So we have got our z as well, and we are done with the 12th question. Okay, so now we will go to the 13th question. So I'm going to show you the 13th question here on the screen only. Again, it is very simple. This is a proof question. So let's start with the 13th one. Again, I'll just want to remind you, if you have not subscribed to my channel yet, make sure you subscribe to my channel and just see all the topics that I'm covering that you can see on my video. And also you will just understand that mathematics is very beautiful if it is taught beautifully. So I hope I'm basically able to do that. Okay, so I'll show you the question over here because like for some reason I'm unable to, paste the question. So this is our question, and okay, so I think there is some issues. I'll just write down the question here directly. So we have fx. Okay, so we have fx given 3 by 3 matrix. So the first entry is cos x. The next entry we have is minus sin x. Then we have 0. And then we have sin x cos x 0. Okay, I'm not sure which screen is shared, so I'm just going to reshare. So yes, so cos x minus sin x 0, and this is going to be sin x cos x 0, and the last entry is 0, 0, 1. This is our fx scale. Okay, what do we need to prove is we need to prove that fx into fy. Okay, we need to prove to show fx times fy is going to be f of x plus y. Let me tell you what is the meaning of this fy and f of x plus y, because fx you can see only, right? So if we have fx, we have cos x, sin x, cos x, and these are going to be 0, 0, 0, and 1, 1, like 1 only. But if we have fy, wherever it is x, that will get replaced with y. If it is x plus y, wherever it is x, again it got replaced with x plus y. That is it. So just we need to start with the LHS. Okay. So fx is already given. That is cos x minus sin x 0. And this is sin x. This is cos x. And this is 0. And this is 0, 0, 1. Now we need to multiply this by fy. So this will become fy is nothing but cos y minus sin y. This is 0. This is sin y. This is cos y. This is 0. This is 0, 0, 1. Now here we have the product of two matrices. Okay. So let me tell you that the product of matrices, the very basic concept and the very basic things I have already cleared in the first part of the video. So if you want to see, like if you want to clear the concept, you can watch that video first. Okay. So here I'm just going to be, like little faster because I have already explained. So yeah, first row, first column. That means this row and this column. Correspondingly, it will get multiplied and then it will get added. So cos x, cos y. Then it is minus sin x, sin y. This is the first entry, and of course the 0 into 0 is 0. Now again the first row only, but the second column. So this is going to be cos x into minus sin y. That means minus cos x sin y. Then minus sin x cos y. So this is minus sin x cos y. And then the next entry is just 0 into 0, which is 0 only. And now again the first row only, but now the third column. So this into 0 is 0, this into 0 is 0, and 0 into 1 is 0 only. So this entry is going to be simply 0. Next is now second row and then the same thing. So let me just write down quickly. Sin x cos y plus cos x sin y, and then 0 times 0 is 0. Now the second row and the second column, so that is minus sin x sin y, and then plus cos x cos y, and then of course this 0 into 0 is 0 only, so no need to write down that. And then the second row and the third entry, so it is going to be 0. Now the next is third row and the first column. So 0 into this is 0, and 0 into this is 0, and 1 into 0 is 0. So this is 0. Now again, this is also going to be 0, and this is going to be 1, because 0 times 0 is 0, plus 0 times 0 is 0, but then plus 1 times 1 is 1. So this is the entry. Okay. Now what do we have? We have simply cos x cos y minus sin x sin y. So let me tell you that this is nothing but this is into a formula. This is a direct formula, and the formula is cos a cos b minus sin b is cos of a plus b. So using that formula, make sure you are writing that formula on the side. I'm just directly writing it here. So by using the formula, this is simply going to be cos x plus y. And here, if I take, minus comma, it is going to be cos x sine y plus sine x cos y. So basically, this is into the formula of sine a cos b plus cos a sine b. And the formula for that is sine of a plus b simply. So here, instead of a and b, we have x and y. So it is x plus y. This is 0 only. And again here, this is sine a cos b plus cos a sine b. Here, there is no negative sign. In this one, I had taken the negative sign common first, and then I use the formula. Here, it is directly into the formula, that is sine x plus y. And this is, of course, this is, if I just write down cos A cos B minus sine A sine B, it's the same thing over here. And that has a formula, that is cos of A plus B. This is 0 only, this is 0 only, this is 0 only, and this is 1. And this is nothing but f of x plus y. So if you notice that this is nothing but our question, the LHS, it's just x got replaced with x plus y, and that is nothing but f of x plus y. And this is what we wanted to prove, hence prove. So I'm also going to write down the two formulas that I have used, because I just want to tell you that you should never forget the formula that you have used. Otherwise, there will be some issue. So yes, I'm writing that. So cos A cos B minus sine A sine B. Okay. So here I'm using, small a, small b, capital A, capital B, small x, small y, capital X, capital Y, whatever you want to use. So this has a formula cos of A plus B. So I have used this formula, and I have used one more formula, that is sine A cos B plus cos A sine B. This has a formula sine of A plus B. Okay, so these two formulas I have used, and we are done with the proof. Okay, so now we can go to the 14th question, because this was our 13th question. So in the 14th question, let me show you the question. I'll try to show you the question. I hope I'll be successful in showing you the 14th question this time. It's like showing some error. But anyway, let's just give one shot to this. Okay, so if I just tell you what is the question, you just check whether I'm successful here or not. Yes. Okay, so this is the 14th question. And you can see we have to show that this product of these two matrices is not equal to the product of these two matrices. Okay, so this is very simple. Just start with the LHS. On the LHS, we have the two matrices that is getting multiplied. So let's multiply it directly. So 5 times 2 is 10, and minus 1 times 3 is minus 3. Next entry, 5 times 1 is 5, minus 1 times 4 is minus 4. Next is 6 times 2 is 12, 7 times 3 is 21. Next is 6 times 1 is 6, and 7 times 4 is 28. So this is our 10 minus 3, 7, 5 minus 4, 1. This is going to be 31, and this is going to be simply 34. So this is our LHS. Now let's simplify the RHS. This is very simple. So clearly 2 times 5, 10, and then 1 times 6 is 6. Next is 2 times minus 1 is minus 2, 1 times 7 is 7. Next is 3 times 5 is 15, 6 times 4 is 24. Next is 3 times minus 1 is minus 3, plus 4 times 7 is 28. So clearly, if you just check, this is 16, this is 5, this is 39, and this is 25. Clearly, LHS is not equal to RHS, and this is what we wanted to show, hence proved. So we are done with this proof as well. Let's move to the second one. Okay, so for the second one, I'm just going to do one thing, and I'm going to show you the question once again, and let's start with the second one. In the second one as well, we need to just prove that the LHS is not equal to RHS. So let's start. Okay, so the second one, let's multiply the matrix directly. Okay, so clearly the first entry is 1 times negative 1 is negative 1, plus 2 times 0, no need to write down, 3 times 2 is 6. Next entry, 1 times 1 is 1, 2 times negative 1 is negative 2, 3 times 3 is 9. If someone is watching this video for the very first time, I know you can say that, how are you doing? You're not explaining. No, I have already explained it in the first part of the video. So make sure you go there and watch it first. Okay, next is 1 times 0 is 0, 2 times 1 is 2, and 3 times 4 is 12. Next is 0 times -1, 0, 1 times 0, 0, and this is 0. Next is this second row and second column. So 0, -1, and then 0. Next is 0, 1, and then 0. Next is 1 times -1 is -1, 1 times 0, and then 0 times 2 is 0 only. Next is 1 times 1 is 1, 1 times -1 is -1, and this is 0 only. And this is 0, this is 1, and then 0. Okay. And this is the matrix looks like this. 5, 9 plus 1, 10, 10 minus 2 is 8, 2 plus 12 is 14, 0 minus 1, 1. I just agree with one thing that if we have, something like this, prove that LHS is not equal to RHS, this is comparatively simple, like for some students, because somehow, like they don't get LHS is equal to RHS and just you can write on the hence proof. The problem is when we have to prove LHS is equal to RHS. Anyway, so this is LHS. So let me write down that. Now let's simplify the RHS. So I'm just doing it here so that you can see the LHS as well. So for the RHS, let us simplify this. It is going to be -1 times 1 is -1, then 1, 0, then 0. Next is -1 times 2 is -2, and then 1, and then 0. Next, -3, then 0. And next, 0, 0, and okay, 1 second. Second row, first column. So 0, 0, and 1. Next, second row, second column. So 0, -1, and 1. Next, 0, 0, 0. Okay. Next is third row, first column. So 2 times 1 is 2, 3 times 0 is 0, 4 times 1 is 4. Next is, you can just see that LHS is not equal to RHS anyhow. So 2 times 2 is 4, 3 times 1 is 3, 4 times 1 is 4. Next is 6, and then 0, and then 0. Okay, so we are getting RHS -1, -1, -3, 1, 0, 0, 6, 11, and 6. So clearly, LHS is not equal to RHS. Hence, proved. It was simple, right? We just was supposed to prove that this is not equal. Okay, so we are done with the 14th question. Now let's move to the 15th question. Okay, so let me show you the 15th question. Again, very simple, not difficult at all. We will just cover all these questions very, very quickly. Okay. All right, so let me show you the 15th question. I'm just trying to paste the question here. I hope I'll be able to paste it. Yes, well done. Okay, so let's start with the 15th one. In the 15th one, we have the matrix A given. We need to find the value of A square minus 5A plus 6i. Let's first find out the value of A square, okay, because this is the product. So A times A, right? So this is 2, 0, 1. This is 2, 1, 3. This is 1, minus 1, 0. Same thing, 2, 0, 1, 2, 1, 3, and then 1, minus 1, 0. So what do we need to do? We need to simplify this. That means we need to find the product. So first row, first column, so 4, and then 0, and then plus 1. Next, 0, because first row, second column, then 0, and then 1. Next is 2, and then 0, and then 0. Next is the second row, first column. Okay, so 2 times 2 is 4, 1 times 2 is 2, and 3 times 1 is 3. Next is 0, then 1, and then -3. Next is second row, third column. So 2 times 1 is 2, 1 times 3 is 3, and 3 times 0 is 0. Next, the third row, first column. So 1 times 2 is 2, -1 times 2 is -2, and then 0. Next, we have 0, -1, and then 0. And next, we have 1, -3, and then 0. So we got the value of A squared. That is 5, 1, 2. This is 9, -2, 5. And this is 0, -1, -2. This is our A square. But we need to find out A square minus 5A plus 6i. So let's write down the value of A square we have already here. And that is 5, 1, 2. This is 9, -2, 5, This is 0, -1, -2. Minus. It's 5 times A. I'm just skipping one step here by not writing 5 and then times A. I'm just multiplying 5 with each entries of A. And that is 10, 0, 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 1 is 5. 5 times -1 is -5. And then 0. We are done with -5A and then plus 6I. What is I here? I is the identity matrix. And let me tell you that the identity matrix is like the diagonal entry is 1 and the others are 0, right? But here we have 6 into I. So wherever it is 1, 6 will get multiplied. So it will become, instead of 1, 1, 1, it has become 6, 6, 6. For 0, 6 into 0 is 0 only. So it is going to be 0. Now this is very simple. We just need to simplify this. So let's simplify it quickly and let's get the answer for A square minus 5A plus 6I. So it is very simple. 5 minus 10. I'm just doing it directly. So 5 minus 10, that is minus 5 and minus 5 plus 6, right? So this minus this plus this. Let me remove this, otherwise it looks like equal sign. So 5 minus 10 is minus 5 plus 6 is 1. So we got the first entry. Next is 1 minus 0, that is 1 and then 0 only. Let me remove this as well. So it is going to be 1. Next is 2 minus 5, that is minus 3 and then 0, so it is minus 3. Next we have 9 minus 10, that is minus 1, so it is minus 1. Next we have minus 2 minus 5, that is minus 7, and minus 7 plus 6 is minus 1. Next we have 5 minus 15, that is minus 10, so minus 10. Next we have 0 minus 5, that is minus 5 only. Next we have minus 1. Minus into minus is plus. So minus 1 plus 5, that is 4. Next we have minus 2, 0 and plus 6. So minus 2 plus 6 is 4. And this is our answer for A squared minus 5A plus 6I. Okay. So we are done with this. Now let's move to the next question. Okay. So I'm going to show you the question once again. All right. So the 16th question you can see here, but I'll just paste the question once again because we have the question with us. Okay, so let's solve the 16th question. In 16th question, we need to prove that this is equal to 0, okay? So let's just, like proving 0 is also a little bit simpler. So A is given, so let's first find out A squared, okay? So A squared is going to be 1, 0, 2, 0, 2, 1. This is 2, 0, 3. A squared, that means A into A, right? Of course. So write down 1, 0, 2, then 0, 2, 1, then 2, 0, 3. We are just going to multiply this, okay? You know how to multiply. So first row, first column, 1, 0, 4. So 1 plus 4 is 5. Next, 0, 0, 0. So it's 0. Next is 2, 0, and 6. So it is 8. All right. Next is second row, first column. So 0, 0, and 2. Next we have 0, 4, 0. So it's 4. Next we have 0. 2 times 1 is 2. And then 1 times 3 is 3. So 2 plus 3 is 5. Next we have 2 times 1 is 2. Then 0 and then 6. So it is simply 8. Next we have 0, 0 and 0. Next we have 4, 0 and 9. So 9 plus 4 is 10, 11, 12, 13. Okay, it's 13. So this is the value of A square, but we need to find out the value of A cube. That means this A square times A. Remember, I'm skipping here some of the steps. You don't skip the steps and you write down it properly. So let's write down the A again. 102, 021, and then 203. Now we need to multiply this to get the value of A cube. Okay. So 5 times 1 is 5, and then 0, and then 16. So 5 plus 16 is 21. Next we have 0, 0, and 0. So the 0. Next we have 5 times 2, 10, then 0, and then 24. So 24 plus 10 is 34. Next we have 2, 0, and 10. So it is 12. Next we have 0. 4 times 2 is 8, and 0. So it is 8 only. Next we have 4 plus 4, 8. Plus 15. So 15 plus 8 is simply 23. Next we have 8, 0, and 26. So 26 plus 8 is going to be 34. Next we have third row, second column. So 0, 0 and 0. And then 8 times 2 is 16, then 0, and then 13 times 3 is 39. So I need to add 39 plus 16, and the answer is 54. So it is 54. So we got the value of a cube. But now a square also we have, right? So this was the value of a square, remember? A we already have, and I is very simple. So now let's put this. So LHS, I'm directly writing it. What is a cube? Let's write down a cube first. So a cube we have 21, 0, 34. This is 12, 8, 23. This is 34, 0, 54. This is the value of a cube. Now next we have minus 6 times a square. This is a square, right? So 6 times this. So let's simplify this. So 6 times 5 is 30, 0, 48, 12, 24, 30, 48, 0, and then 13 times 6. So what's the answer of 13 times 6? 78. Okay. And then plus 7a. So 7 times this is a, right? So 7, 0, 14, 0, 14, 7, 14, 0, 21. 7a is done plus 2i, right? Remember here I is the identity matrix, and the order of identity matrix is the same as the order of the matrix given in the question. So it is also going to be 1, 1, 1, and then the rest 0. 1, 1, 1 as the diagonal entry. So of course 2 multiplied by that is 2, 2, 2, and the rest entries are going to be 0. All right, so now we need to simplify this. So let us simplify this quickly, and let's check what is our answer. Okay. All right, so yes. So clearly you can see that this is 21 minus 30 plus 7 plus 2. If you simplify this, it is 21 plus 7, 28, 28 plus 2, 30, and 30 minus 30 is 0. Next is 0, 0, 0, 0. So it's 0 only. Next is 34 plus 14, and that is 48, and 48 minus 48 is 0. Next entry, 12 minus 12 is 0, and then it's 0 only. Next, 8 minus 24, that is minus 16, and minus 16, and here 14 plus 2, that is plus 16. So minus 16 plus 16 is 0. Next, we have 23 minus 7 is minus 7, and minus 7 plus 7 is 0. Next, we have 34 minus 48. So I'll do 34 plus 40, that is 48. 48 minus 48 is 0. This is 0 plus 0, 0. So it's 0. Next is 54 plus 21 plus 2. So it is 23. And 54 plus 23 is 78, and 78 minus 78 is 0. Okay. So this is 0, and you can see that this is nothing but our RHS. We wanted to prove that like a cube minus 7a square, a cube minus a square plus 7a plus 2i, that we were supposed to prove 0 only. And this 0 matrix is same as 0. So this is the RHS, hence proved. All right, so we are done with this. Now we can go to the next question. So let's quickly go to the next question. And the next question is our 17th question. Okay. So we have given a, we have given I, we have to find the value of k, so that a squared equals ka minus 2i. So let's first write down a squared equals k times a minus 2i. Remember, we need to find here the value of k. So let us first write down a square. So this is a 2 by 2 matrix. So comparatively easier to find the product of the matrix. So it's 3 minus 2, and this is 4 minus 2. This times the same matrix, 3 minus 2, 4 minus 2 is equal to k times a, right? So what is the meaning of k times a? That means 3 times k minus 2k, 4k, and minus 2k. And then minus 2i, right? So of course 2 times I is 1001. It is going to be 2002. Let's simplify this. Of course, if you simplify this, you will get 3 times 3 is 9, and minus 8, that is 1. Next is 3 times negative 2, that is negative 6 plus 4. Negative 6 plus 4 is negative 2. Next is 12 minus 8, that is 4. Next we have negative 8 plus 4. That is going to be negative 4. Okay. And this equals, this is 3k minus 2. This is minus 2k only. This is 4k only. And this is minus 2k minus 2. We can see here that we are having two equal matrices. And we know that if the matrices are equal, their corresponding entries are equal. So if I just equate this, 3k minus 2 equals 1. I'm getting 3k equals 1 plus 2, that is 3. So k is equal to 1. Even if I simplify, or if I take any other thing, like this is equal to this. So clearly minus 2k equals minus 2. That means k equals minus 2 divided by minus 2, that is 1 only. So here also 1. Even if you do this, 1. Even if you do this, it is going to be 1 only. So what is the value of k? The value of k is 1. So for what value of k? This a square equals ka minus 2i. So for the value of k equals 1. All right, let's move to the next question, and that is going to be our 18th question. Okay. All right, so 18th question, let me show you that first. Yes. Let me tell you that the last two questions are just the multiple choice questions. So this, we are just going to finish it very quickly. Now we will just take time to solve this particular question. So now let's start. So you can see that we have the matrix A given and I is the identity matrix. We need to show this particular thing. Okay. So for that, what we are going to do, we will simply take the LHS and RHS. So on the okay. So on the left hand side, what do we have? We have I plus A. What is the meaning of I? It's 1, 0, 0, 1. And A, that means we have to add it. It's very simple. 0 minus tan alpha by 2. And this is tan alpha by 2. And this is 0. So if you add this, it is going to be 1 plus 0. 1, this is going to be minus tan alpha by 2 only. And this is going to be tan alpha by 2. And this is 1 plus 0 is going to be 1. So this is your LHS. Okay. Now, let's find out the RHS. So on the RHS, we have I minus A, right? So that means if I just consider here, it is this only. So let's simplify it directly. So 1 minus 0 is 1 only. 0 minus minus tan alpha by 2. So it will become plus tan alpha by 2. This will become 0 minus tan alpha, that means minus tan alpha by 2. And this will become 1 minus 0, that is 1. So we have I plus A. Like on the LHS, and we have I minus A. But now we have on the right hand side I minus A times something. So let me write down that as well, and let me write down that we are solving the RHS here. Okay. So this times cos alpha minus sin alpha, and this is sin alpha cos alpha. Okay. All right, so now we need to do the product here. So let's simplify this, and this is, trust me, very, very simple. So, okay, so if you simplify this, this is going to be 1 times cos alpha is cos alpha plus tan alpha by 2 sin alpha. This is the first entry. Next is minus sin alpha plus tan alpha by 2 cos alpha. Little complicated. Okay. This is minus tan alpha by 2 cos alpha plus sin alpha. And the next is minus into minus is plus. So tan alpha by 2 sin alpha plus cos alpha. Now to simplify this, we need a greater space or bigger space, I must say. And now let's simplify this. Okay. How we will simplify this? By converting this tan alpha by 2 as sine upon cos. We know that tan theta is sine theta upon cos theta. So that we are going to do in the next step, but I'm going to do it here only. So tan alpha by 2 will become simply sine alpha by 2 upon cos alpha by 2. This is sine alpha by 2 upon cos alpha by 2. All right. Okay. One second. Okay, yes. Okay, so now, and this will become tan alpha by 2. So this will become again sin alpha by 2 cos alpha by 2. This is sin alpha by 2 upon cos alpha by 2. And here also this will become sin alpha by 2 cos alpha by 2, and here as well. Okay. That you are supposed to do it in the next step. Remember this, sin alpha by 2 upon cos alpha by 2. And here this will become sin alpha by 2 upon cos alpha by 2. Now, if you simplify the first entry, okay, if you take LCM, this will become cos alpha by 2 plus sin alpha by 2 as it is, sin alpha as it is, and this will become upon whole cos alpha by 2 because we have taken LCM. Next is going to be, if you simplify this, so minus sin alpha, okay, cos alpha by 2 plus sin alpha by 2 cos alpha, and that upon cos alpha by 2. Okay. Now the next entry is going to be, of course, your minus sin alpha by 2 cos alpha plus sin alpha times cos alpha by 2. We are taking just LCM upon the cos alpha by 2. Next is sin alpha by 2 sin alpha plus cos alpha times cos alpha by 2 upon cos alpha by 2. And then we can close the case. Okay, so now you can see a lot of sin and cos. We are simply going to simplify this by using formulas, okay? So let me tell you that this is into the formula of cos A cos B plus sin A sin B. And this has a formula cos A minus B. So this will become simply cos alpha minus alpha by 2. Okay, and this is of course cos alpha by 2. This is our first entry. Now next is, if you just look here, this is sin A cos B minus cos A sin B. This has a formula sin A minus B. So this will simply become sin A, that means alpha by 2 minus alpha upon, of course, cos alpha by 2. And let's write down the next entry. So here this is sin A cos B minus cos A sin B. So again it is going to be sin alpha minus alpha by 2 upon cos alpha by 2. Right? And this will become sin A cos, okay, cos A cos B plus sin A sin B. So it is simply going to be cos of A minus B. That means alpha minus alpha by 2 upon cos alpha by 2. All right, so we have got this step. Now after this, what do we need to do? We are simply going to use a formula here. Okay, let's just check the question once. One second. Okay, all right. So now this will become very simple. If you simplify this, it will simply become, if you take LCM here, so it is 2 alpha minus alpha, that is alpha only. So this is simply going to be cos alpha by 2 and then upon cos alpha by 2. This will become, if you simplify this, sine minus alpha by 2. But you know that sine of minus theta is just sine, minus of sine theta, right? So this will become minus sine alpha by 2 and this is cos alpha by 2. This will become sine 2 alpha minus alpha, that is alpha by 2 only, and upon cos alpha by 2 as it is. And this will become cos alpha, if you take LCM, 2 alpha minus alpha, that is alpha only, so alpha by 2 upon cos alpha by 2. Now this is looking so simple. This is of course 1, this is minus, we know that sine alpha by 2, cos alpha by 2, it is tan alpha by 2 because that's the formula. This is tan alpha by 2 and this is 1, and you can see that this is what we wanted to show, that this RHS should be equal to the LHS. So this is your RHS. Let's just check what was the LHS by after doing I plus A, and you can see that it is the same thing. So we got LHS is equal to RHS verified, and we are done. Okay, so we are done with this question. Now let's move to the next question, and that is question number, check. So this is going to be question number 19. Okay, so let me explain this question because this is a word problem. So for that, I need to show you the question first. One second. All right, so let's start with the 19th question. And let me show you the 19th question here. That is a word. Okay. All right, so I'll read the question because it's NCERT. So I just want you to, check the question from your book. So the question number 19 says, let me write down the question number 19 here. I'll just do one thing. I'll try to paste the question once again. Maybe it will work. Otherwise, let me try once again. So at least I'll read the question so that you can understand that I'm talking about question number 19. So question number 19 is, a trust fund has rupees 30,000. Okay, I'm just trying it once. All right, so it's not coming. So I'll read the question then. So a trust fund has rupees 30,000 that must be invested in two different types of bonds. The first bond pays 5% interest per year, and the second bond pays 7% interest per year. Using matrix multiplication, determine how to divide rupees 30,000 among the two types of bonds that the trust fund must obtain an annual total interest of rupees 1,800, and the second part is 2,000. That means this 1,800 and this 2,000 is the product given. Okay. So now the very first thing that we are going to do is we will have to write down some of the things here. So we need to write down, let X be the investment. Okay. One second. Yes. So let X be the investment in the first one. So if in the first one, the investment is X, then it's very simple that the investment in the second bond will be 30,000 minus X because that is the total. So the investment in the second bond is going to be simply 30. Okay, let me just erase this. So this is 30,000 minus X. Okay. All right. Now next is interest paid by the first bond is 5% per year, and interest paid by the second bond is 7% per year, right? So if I just write down the matrix of investment, it is X and the second is 30,000 minus X. Now, what is the matrix of the annual interest per year? That is 5% and 7%. So that matrix interest I'm going to write down 5%, that means 5 upon 100, and 7%, that means 7 upon 100 in the column form. Okay. Now, the product of these two is given 1,800. Okay. So let me write down that this is nothing but 1,800. So if you simplify this, it's very simple. The first row with the first column, so that means 5x upon 100, and then plus 7 upon 100 times 30,000 minus X, and that is equal to 1,800. So you can clearly see that you have already got an equation, okay, and you need to simplify this equation simply. So let's simplify this. So if you simplify this, this is going to be 5x upon 100 as it is, and this will become clearly this will get cancelled, this will get cancelled, so you're getting 7 times 3 is 21, and then of course 00, okay, and then minus 7 upon 100x equals 1,800. Now if you simplify this, this is 2100, shift 1,800 to this side, so minus 1,800, minus 7 upon 100 will become 7 upon 100x, and this will become 5x upon 100. So clearly 2100 minus 1800 is 300. And if you simplify this, it is 7x minus 5x, that is 2x upon 100. We want to find the value of x. So that is going to be 300 times 100 upon 2. So it is 5 times 3 is 15, and then 000. So x is 15,000. That means the investment in the first one that we had taken as x is nothing but 5,000. So that's the answer. And the investment in the second bond is simply 30,000 minus 5,000, that is 25,000. Okay. So yes, you can write down here. Therefore, investment in the first bond that we had taken as x, that we got 15,000. So automatically the investment in the second bond, that was 30,000 minus x, so it will become 30,000 minus x, that is 15,000. Oh, I'm making some mistake. No. Let me check. No, it is correct. So the second is going to be simply 30 minus 15, that is 15,000 only. Okay, if I'm just let me check whether I'm doing any mistake or not. So it's 2x is 300, 300 times 100. I'm fine, upon 2, that is, yeah, of course, that is correct. Okay, now the second part where the matrix, the multiplication was, check. Okay. Okay, so this was the first question where we got 1800. Now in the second one, we have the product 2000. Okay, so it's the same thing, and then this time the product is going to be 2000. So let's start. So this time it is going to be x, and the second is of course 30,000, 30,000, sorry, 30,000 minus x, and the interest was 5 and 100 only, of course 5% and 7%, that is 5 upon 100, 7 upon 100. It's just the product is going to be 2000 this time. That is the only difference. Otherwise, the steps and everything is same only. So if you know that we had got here the linear equation form, so you can directly do that. So that was 2100 minus 2000 this time. Okay, so it's 2100 minus 2000, and this was 7x upon 100 minus 5x upon 100, right? So this is clearly 100, and this is 2x upon 100. So therefore x is going to be 2, okay, 100 times 100, and then it's 2. So it's simply going to be 5,000. So the x is 5,000. That is the investment in the first bond. So in the second question, the second part of the question, the investment in the first bond is 5,000. So automatically the investment in the second bond is going to be 30,000 minus x, that means 30,000 minus 5. So investment in the second bond is going to be 30,000 minus x, x is 5,000, so it is simply going to be 25,000, and that's the answer. So we are done with the 19th question as well. Now it's time to move to 20th question. We have only 22 questions, okay? So let's just figure out the answer quickly. The next is again a word problem, and then after that the last two questions are just the multiple choice question, and that is super simple. It is looking difficult, so if your basic is clear, if the concept is clear, the last two questions are going to be very simple. Okay. All right, so let's do the third last question, and yes, that was expected. Anyway, so I'm going to read out the question loud, and we will start with the solution. So the question is, the bookshop of a particular school has 10 dozen chemistry books, 8 dozen physics books, 10 dozen economics books. Their selling prices are rupees 80, rupees 60, and rupees 40 each respectively. I'm reading the question. You can see the question from the book. Find the total amount the bookshop will receive from selling all the books using matrix algebra, assuming X, Y, Z, W, and P are the matrices of the order 2 cross N. Okay, here the two questions are mixed. Okay, so I'll just read it till. Find the total amount the bookshop will receive from selling all the books using matrix algebra. So we are going to simplify question number 20 by first writing the selling price of each book. Okay, so let the selling price, short form is SP. So let the selling price of each book in a matrix form. So I'm writing in a column matrix form, and that is actually it's like you can say 3 by 1 matrix. Okay, instead of saying column or row. So the first is 80, next is 60, and the last one is 40. Okay. Now, the total amount received by selling all the books is just, we are going to multiply this selling price with the number of books, right? So the number of books that we have, like, that the bookshop is having, that is 10, 8, and 10, right? So let's multiply 10, 8, and 10. And this multiply by this selling price, that is 80, 60, and 40. Now here I want to just clear one thing, that this 10, 8, and 10 are not the number of books. This 10, 8, and 10 are actually the dozens, right? But we need to write down the number of books. So that is why you are going to multiply this by 12. Because we know that in one dozen we have 12 items, okay? So this is equal to, we are having the selling prices as well. Okay, so we just need to multiply this and we'll get the answer. So first of all, it is going to be 120. This is 96 and this is 120. So that will just give us the total price, okay? And this is, okay, this is 80, this is 60, and this is 40, all right? Now, if you simplify this, it is simply going to be 120 times 80. So I know that 12 times 8 is 96, so it is going to be 96 and then 20 plus 96 times 60. So I just need to find out what is 96 times 6. So it is going to be 576 and then 0 as well. Plus, but 20 times 40, this is simple. This is 48 and then double 0. Okay. So this is the total. If you add this, 5760, 4800, and 9600. It is 0, 6. Then this is 8 plus 7, that is 15 plus 6 by 1, 1. And then 5 plus 4, 9, 9 plus 9, 18, 18 plus 2, 20. So it is 20160. Okay. So therefore, the total amount received by selling all the books is simply 20,116 rupees. That's the answer. Okay, so now we are good to go with the last two questions, and all, like, the last two questions are MCQs. Okay. So let's just finish out those two questions and we are done with our video for today. All right, so let me show you the question. I'll just try the question. Oh, yes, finally the question came. Okay, so 21st question. First of all, you can see, assume X, Y, Z, W, and T are the matrices of order 2 cross N. That means X has the order 2 cross N. Y, 3 cross K. Z, 2 cross P. W, N cross 3, and P is P cross K. Choose the correct answer. Okay, so the 21st question, the restriction on N, K, and P so that Py plus Wy will be defined are. So let me write down first Py plus Wy. What is the meaning of Py? That means P times Y. And what is the meaning of Wy? That means W times Y. Now, P times Y, we know that the matrix multiplication is possible only with one condition. So let me write down that. So P, the order is P cross K times Y, the order of Y is 3 cross K, right? So here you can see that this and this are equal, right? Why this is equal? Because P cross Y will be valid only if this and this are same. So it also tells you that K is equal to 3. Keep that aside, but K is equal to 3, that means this is 3 and 3, and if these are same, that means the resultant will have the order this cross this. This is the rule, okay? So the resultant will have the order, that means Py should have the order P cross K, okay? Plus W cross Y. So W order is N by 3 and Y order is 3 by K. This is very simple. This is 3 and 3. So the resultant will have the order N cross K. So this is WY and this is going to be N cross K. Now here, let me tell you from this, it is very simple that you need to, like, you can add these two matrices only if their orders are same. Otherwise, it's not possible to add the matrices, okay? So that simply means because this K is equal to K only, like K and K are same. So it should be that P is equal to N, okay? Right? Otherwise, there is no other condition. This is K, right? And this is K. They are same only, right? So what need to be equal? P and N should be equal. That is why P is equal to N. P is equal to N, and we have another information that K is also equal to N. Choose the correct option. K is arbitrary and P is equal to 2. No, we can't say that. P is arbitrary and K is equal to 3. Okay, K is equal to 3, that is correct, but P is not arbitrary. P is equal to N only. And K is equal to 2, P is equal to 3, that is also not correct. So the correct option is option A. Okay, now let's move to the second question, that is, if n is equal to p, then the order of the matrix 7x minus 5z. So let me start here. It is given n is equal to p. 7x, what is the order of x? 2 cross n, right? And then minus 5z, the order of z is 2 cross p, right? So here, what it says that n is equal to p. That means you can just write down this as x. N is equal to p, that means 2 cross p minus, this is 5z, and this is going to be 2 cross p only, right? So that means what is the order? Order has to be 2 cross p, right? Okay, 2 cross p. Or we can also do one thing. I can write down 7x as it is, and this is 2 cross n, okay? And then this is minus 5z t, right? So p is n because p is equal to n, so I can write down 2 cross n. That means the order has to be, it's either it can be 2 cross p or it can be 2 cross n. But we do not have 2 cross p. That means p cross 2. Remember, 2 cross p and p cross 2, they are different. So this is incorrect. 2 cross n, we have 2 cross n. So that is why 2 cross n is the answer. We do not have this, we do not have this. That is why the answer is 2 cross n. So the correct answer is option B. Okay, and we are done with the solutions of exercise 3.2 completely. The first part, question number 1 to 11, that is the first part, that is in the link in the description box. The link is in the description box, and this is the second part where I completed the entire exercise. I hope you understood the solution, and just let me know in the comment section whether you are understanding all these solutions or not. Thank you so much for watching my channel. Again, I'll just remind you that if you have not subscribed to my channel yet, make sure you subscribe to my channel. Thank you so much. I'll see you super soon.